Laws of indices. Get your books and pens for study.
Welcome to class. This morning we'll be looking at the concept of indices. Indices is a concept that has to do with exponents, powers. For example, in your previous classes, you must have learned that when you see a thing like this, 2 raised to power 3 means 2 multiplying itself in 3 places. That is 2 times 2 times 2. 2 multiplying itself in 3 places. In this case, 2 is called the base, while 3 is the exponent or power. We call it power or exponent or index. We can call it any of this. 2 is the base. 3 is the power, the exponent, or the index. Index is the singular, and the plural is indices. That is how we come about indices. So when I'm talking about the concept of indices, we'll be looking at a lot of powers and operations that has to do with them. Another example is writing something like this: a raised to power 5. Can you tell me in this case what my base is and what the exponent is? A in this case is my base, while 5 is the exponent, the index, the power, whichever you choose to use. In the course of teaching this course, I'll be using the 3 words interchangeably. So when I'm talking about power, you know I'm referring to the exponents. I'm also referring to the index. So in this case where I have a raised to power 5, that means a multiplying itself in 5 places. A multiplying itself in 5 places. That is the meaning of a raised to power 5. There are laws governing the operations with indices. Let us quickly look at these laws. Laws of indices. We'll be looking at about 8 laws governing the operations with indices. The first law we'll look at this today is the multiplication law. Multiplication law. The multiplication law says if I have a that is raised to power m and I'm multiplying another a that is raised to power n, the law says I should add the power of since the bases are the same, I should add the exponents, the power. That is a raised to power m times a raised to power n equals to a raised to power m plus n. Let us study this law a little. For example, if I have 2 raised to power 3 times 2 raised to power 5, 2 raised to power 3, I know that it is 2 times 2 times 2. That is 2 raised to power 3. Then this multiplication and 2 raised to power 5 means 2 multiplying itself in 5 places. By the time you look at all of this, you will be seeing 2, opening the bracket up, you'll be seeing 2 multiplying itself in a total of 8 places. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 multiplying itself in 8 places, thereby establishing the law that instead of expressing in this elaborate form, I can just say, since the bases are the same, I'll pick a base and add the powers, which is 3 plus 5, which is equals to 2 raised to power 8. 2 multiplying itself in 8 places. That is the multiplication law. Let us take more examples under the multiplication law. For example, it is possible I have x, which is raised to power 2 plus another x, which is raised to power 1. Without writing the 1 here, this is actually x raised to power 1. Most of the time, when the power is positive 1, it is usually skipped. So when you see x like this, the power is not written. That means it is raised to positive power of 1. It is raised to positive power of 1. So here I have x raised to power 2 times x raised to power 1. This means I have x, since the bases are the same, that is x raised to power 2 plus 1, which is equals to x raised to power 3. Yes, we go to the second law, which is the division law. The division law of indices. Looking at the division law, the division law states that if I have a, which is raised to power m, being divided by another a raised to power n, the law says since the bases are the same, I should take one of the base and subtract the exponents, subtract the power m minus n. This is the division law of indices. A raised to power m divided by a raised to power n equals to a raised to power m minus n. This simply can be established with examples. Let us say, for example, I have 3 raised to power 5 divided by 3 raised to power 2. In the elaborate form, 3 raised to power 5 can be written as 3 times 3 times 3 times 3 times 3. That is 3 multiplying itself in 5 places, divided by 3 multiplying itself in 2 places, 3 times 3. In this elaborate form, we can say 3 divides 3 1, 3 divides 3 1, 3 divides 3 1, 3 divides 3 1, so that I have it equals to 3 raised to power 1, 2, 3. 3 multiplying itself in 3 places. To establish this law, the law says instead of going through this expression, I can just say, since the bases are equal, I'll pick a base and subtract the powers, which is 3 raised to power 5 minus 2, which will give me 3 raised to power 3. Very short, concise, and correct. That is all about the division law of indices. You can have a non-numerical example where y raised to power 4 is divided by y raised to power 3. In this case, instead of going so expressive, that elaborate form, the law says I should just say it means y, since the bases are the same, raised to power 4 minus 3, which is the same thing as y raised to power 1. And that is the same thing you are going to find using the elaborate form. we are left with a single y, which is y raised to power 1. The power law says if I have a situation where a is raised to power m and the entire raised power a raised power m is raised to another power of m, this law says I can just multiply the powers, the two exponents, the indices. This means I have a, which is raised to power m times n. A raised to power m times n. M times n is mn. So that is a raised to power mn. Let us look at a numerical example to drive home this law. For example, given that I have 5 raised to power 2 and the entire 5 raised to power 2 raised to another power of 3. Or in a simpler form, let's say I have a 2 raised to power of 3 and the entire 2 raised to power 3 is raised to a power of 2. In the elaborate form, you know that in the brackets, what I have is 2 multiplying itself in 3 places, which is 2 times 2 times 2. All the 2 raised to power 3 is raised to another power. On the brackets, I have 2 times 2 times 2 raised to power 3, which is 8. And the 8 in the bracket is raised to a power of 2, which is 8 times 8, giving me 64. Going by the power law, it makes it a lot simpler. This means I have 2 raised to the product of 3 and 2. 3 times 2, which is the product power law. The product power law is such that if I have AB, which is raised to the power everything, this product AB are both raised to the power of n. The bracket encloses this product and the entire is raised to the power of n. The power here, since there is a bracket that encloses this product AB, the power will distribute itself over each of the terms in the bracket. This is it. This means I have A is raised to power m and B also is raised to power m. Yes, because of the bracket and everything is raised to power n. This is what I have. It is possible for us to have a numerical example like this, where I have 2 times 3, everything raised to power 5. In this case, this means I have 2 raised to power 5 and 3 raised to power 5. That is what I have. 2 raised to power 5 multiplied by 3 raised to power 5. That is the meaning of this law. The fifth law I'll be looking at this morning is the zero index law, where I have a power of 0. The law says anything that is raised to the power, the law says anything that is raised to the power of 0 is equals to 1. Let us prove this law. For example, if I have a raised to power 2 divided by a raised to power 2, Remember the law of division, which says when we have the same base dividing each other like this, it means we can say we have a raised power 2 minus 2, 2 minus 2, which is equals to a raised power 0. In the expressive form, I can say I have a times a, that is a raised power 2, divided by a times a. A divides a is what? A divides a is 1. A divides a is 1. A divides a giving 1, which means my answer is equal to 1, implicating that the a raised power 0 I have here is actually equivalent to 1. A raised power 0 is equals to 1. Not only a, anytime you see a 0 index, even when it is 1 million, when 1 million is raised to the power of 0, it is equals to 1. That is the implication. Whatever number, however big it is equals to 1. Negative index law. The negative index law states that when I have a that is raised to the power of a negative number, for instance, a raised to power minus 1, this means I have the inverse of a raised to power 1. A raised to power negative 1 means the inverse, the negative, shows inverse. The negative shows inverse of a raised to power 1. Inverse of a raised to power 1. What about if the a is raised to power minus 2? Yes, it's the same thing. The negative means 1 over the inverse of a raised to power 2, a squared. So, in a numerical case where I have 2 raised to power minus 3, that is 1 over 2 raised to power 3, which is the same thing as 1 over 8. That is that about the negative index law. The root law states that if I have the square root of a, the square root of a is represented as a raised to power 1 over 2, a raised to power half. That is the square root of a. The cube root of x, that is x raised to power 1 over 3. I can as well have the fifth root of y. That will just be y raised to the power of 1 over 5. That is the fifth root of y. Numerical examples are when I have cube root of 8. Cube root of 8 can be written as 8 raised to power 1 over 3. And as you know, the cube root of 8 is 2. So 8 raised to power 1 over 3 is actually equals to 2, the cube root of 8. Another example is when I have 64 raised to power 1 over 5. Another example is when I have 32 raised to power 1 over 5. This simply means the fifth root of 32. The fifth root of 32. And the fifth root of 32, just like you know, is 2. Because 2 multiplying itself in 5 places gives 32. That is all about the root law. The fractional index law is very similar to the root law. Look at it. When I have a raised to power m over n, we know that m over n can be written as 1 over n times n over 1. Do you remember multiplication of fractions? The multiplication of fractions is done by multiplying numerator by numerator and denominator by denominator. So m over n has been split into 1 over n times m over 1. This means I have, you remember, the root law says that when I have 1 over n, that means the nth root of a, nth root of a raised to power n. The nth root of a raised to power n. That is the application of a fractional index law. Numerically, I can pick 64. 64 raised to power, let me say 5 over 6. 64 raised to the power of 5 over 6 is the same thing as saying 64 raised to power 1 over 6 times 5 over 1. 64 raised to power 1 over 6 now in brackets is raised to another power of 5. 64 raised to power 1 over 6 is the sixth root of 64. The sixth root of 64. The sixth root of 64 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and times 2 is 64. So I have the sixth root of 64 raised to the power of 5, which is 2 raised to power 5. The entire in the bracket, which is the sixth root of 64, is 2. Raised to the power of 5, that is 32. And that is all about the fractional index law. Right now, we'll be looking at examples, more examples. 32 raised to power 3 over 5. That means we are starting from the application of the fractional index. This is the same thing as saying the denominator is 5. Going by the splitting, this is 1 over 5 times 3, which is the fifth root of 32 raised to the power of 3. Fifth root of 32. Everything raised to the power of 3. Yes, I can hear you say the fifth root of 32 is 2. So I have 2 raised to the power 3. This is equals to 8. That is 32 raised to the power 3 over 5 is equal to 8. Number 2. 343 raised to the power 1 over 3. You remember the root law that we have applied here. That is cube root of 343. The cube root of 343. And that is 7. The cube root of 343, that is 7. Number 3, I have 64 raised power 2 over 3. That is fractional index law. This can be written as 64 raised power 1 over 3 times 2. 64 raised power 1 over 3 is equals to 60, the cube root of 64, everything. What is the cube root of 64? I can hear you say that is 4. The cube root of 64 is 4. So it means we have 4 raised power 2, which is 16. Which is 16. 0.001. I'll take you quickly back to your basic. When we have 0.001, we have to convert it first to regular fraction, where you have a numerator and a denominator. So this is 1, 2, 3. So in this case, I can say what I have is 1 over 1, 2, 3, that is 1,000. The number of decimal places must resonate with the number of zeros you have here. So having 3 decimal places makes it over 1,000. So 1 over 1,000, which is the same thing as 1 over, we know that 1,000 is 10 raised to power 3. 10 multiplying itself in 3 places. So what I have now, remember the negative power law, which says that when I have a raised to power minus 1, it means 1 over a. When I have a raised to power minus 2, it means 1 over a raised to power 2. So 1 over 10 raised to power 3 can be worked back and be written as 10 raised to power minus 3. The minus coming because of the inverse. That is 10 raised to power minus 3. 0.001 is the same thing as 1 over 1,000, same as 1 over 10 raised to power 3, which gives 10 raised to power minus 3. Number 5, let us consider, of course, our dear friend, zero index. Anything raised to power 0. What did I call it? I told you it is equal to 1. So that is a very cheap example there. 14 raised to power 0 is equal to 1. It is a law we have proven previously. Number 6, I have 25 raised to power 1.5. Yes, I believe you still remember that this is a fraction. This is a decimal fraction. Because it is a fraction, then that makes it a fractional index. This is 25. Converting 1.5 to a regular fraction of numerator and denominator. You know, 1.5 can be written as, you write the two together, 15 over how many decimal places? 1. That is 10. So 1.5 is actually 15 over 10. Reducing it to the lowest term, 5 divides 15 3 times, 5 divides 10 2 times. This is equals to 3 over 2. Meaning that my 25 raised to power 1.5 is the same thing as saying 25 raised to the power of 3 over 2. Fractional index can be written as 25 raised to power 1 over 2 multiplied by 3. Remember, 25 raised to power 1 over 2 simply means the square root of 25. The square root of 25, everything raised to power 3. The square root of 25 gives 5. Square root of 25 gives 5, and 5 raised to power 3, which is going to give me 125. 125. Which means 25 raised to power 1.5 gives 125. Thank you. See you in the next class.